So in this video we're going to talk about solving multiple systems of equations simultaneously when their coefficient matrices are the same. So in this example, what we want to notice is that each equation in each row is exactly the same with the exception that the constant term has been changed. So row 1 has coefficients 1, -1, 3 for all three equations. In row 2, the coefficient matrices are 2, -1, and 4 for all three equations. And in row 3, the coefficient matrices would be -1, 2, and -4 for all three matrices. So if you were asked to solve these, you could set up individual augmented matrices, 1, -1, 3, and 8 for the first row. This one would be 2, -1, 4, and 11 for row 2. Row 3 would be -1, 2, -4, and -11. And then you'd step over and you'd set up this matrix. But the coefficient matrix is going to be identical. So you're going to get 1, -1, 3, 2, -1, 4, -1, 2, -4, and only the constant terms are different, 0, 1, 2. And it would be the same bit for this system of three equations and three unknowns. The coefficient matrices are the same, 2, -1, 4, -1, 2, -4, augmented with 3, 3, -4. So the idea is if we were to set up three individual augmented matrices and solve them, the row operations, the elementary row operations that we would apply to each matrix would be exactly the same. To get a leading 1, we would do the same thing for all three matrices. To zero out the two terms underneath the leading 1, we would make exactly the same moves. It would be repetitive to solve these matrices independently because the row operations needed to put them into reduced row echelon form are not affected by the constants. The constants have no say in what you're doing. In fact, when you're putting it into reduced row echelon form, you're really manipulating the coefficient matrix. And the constant column is coming along for the ride. So what we could do is just create a larger augmented matrix. I could say here is the coefficient matrix. And augment it with each of the constant columns. 8, 11, -11, 0, 1, 2, and 3, 3, -4. And now we can just apply our elementary row operations to this larger augmented matrix and do the work one time. I'm not going to go through the steps of reducing this one, but in the homework assignment, what I guarantee you is there's a problem in there that the intention is for you to do this so that you're running through the elementary row operations only one time. And even though the intent of the problem is that students will do it this way, 9 out of every 10 students sets up three separate matrices and solves them individually. So heads up, there's an easier way to do it. The row operations are going to be the same. You would just be doing the same thing over and over again. Just do one large augmented matrix.